Alright, this is number 16.66. There's two charges, a plus q right there and a minus q there, that are both A away from the x-axis, and then there's a point P that's x from the origin. The question is, what is the E field at point P equal to? If you label it in terms of the arrows for the direction, due to this charge here, you're going to get a field in that direction. And due to this charge over here, you're going to get a field in that direction. Because A, well not A, but the distance, I'll do a dashed line, from where the charge is to point P is the same for both of them, which is A squared plus x squared square rooted. It's the same for this and for this. Your magnitude of your fields is the same for both, so hopefully you recognize right away that this x component and this x component are going to cancel each other out. You'll also notice that the y components are equal, so really the answer is going to be 2 times one of the y components, or ey plus ey equals 2ey, because they're equal vectors. So what we have to do is just find E and then find the y component and then double it. So E at that point is equal to k q1 q2 over r squared, which is k q q over, I already said it was the square root of a squared plus x squared, but when you square that right there, you get a squared plus x squared with no square root. So that's the solution for what EY is. Now, or excuse me, that's what E is. Now we need to find the y component. The y component is going to be that answer times the sine of theta, where theta is this angle right here. And if you think about it, this theta is the same as this theta here. And so if this is theta, the sine of theta, if you look at the entire picture here, is opposite over hypotenuse, right? So opposite over hypotenuse is a over the square root of a squared plus x squared. So if I plug, I don't even have to figure out what theta is. I can plug in what the sine of theta is there, and I get k, q times q is q squared, over a squared plus x squared times a over a squared plus x squared square rooted, right? That's what we got here. And I got to remember to double it. So that's my answer. I can reduce this a little bit. Let me quick erase all these strokes. So I have 2kq squared over a squared plus x squared times a over the square root of a squared plus x squared. This is the same as to the 1 power. Instead of the square root, we can say it's this to the 1/2 power, which means you get 2kq squared a over a squared plus x squared to the 3/2 power. When you multiply the exponents, you get 1/2. And that is your solution.